Download this code from codegive.com, link in the description below. Handling runtime errors in next.js 13 nested routes, a comprehensive guide. Next.js 13, with its app router and server components, introduces a powerful and flexible approach to building React applications. However, managing runtime errors in this new paradigm requires a deeper understanding of error boundaries, error handling strategies, and the nuances of server-side rendering. This tutorial will provide a detailed guide to effectively handle runtime errors in your next.js 13 nested routes, complete with practical code examples. Understanding the landscape *. Before diving into implementation, let's establish the context. Server components *. These components run exclusively on the server. They are great for data fetching, accessing server-side resources, and improving initial load times. Errors in server components can lead to server crashes or incomplete responses. Client components *. These are the traditional React components that run in the browser. They're necessary for interactive elements, state management, and client-side logic. Errors here impact the user experience and can break the application. App router *. This router is built on the React server components architecture, facilitating a file system-based routing system. The structure of your directories maps directly to the routes in your application. Error boundaries * React components that catch JavaScript errors anywhere in their child component tree, log those errors, and display a fallback UI instead of crashing the whole component tree. Next.js 13 extends this concept with specialized error.js files within your root segments. Error.js files * These files are React server components that define how your application handles errors within a specific root segment. When an unhandled error occurs in a component rendered within that segment, including its children, Next.js will render the error.js component. They can be custom designed to display user-friendly error messages, retry functionalities, or redirect to other pages. Types of errors to handle *. Data fetching errors * Errors that occur when fetching data from an API or database. Rendering errors * Errors that occur during the rendering process, especially on the server. Client-side errors * Errors that occur due to client-side JavaScript code. Unexpected errors * Any other errors that might occur in your application, especially on the server. Strategies and implementation *. Let's explore different approaches for error handling, along with code examples. 1. Leveraging error.js for root-specific error handling ***. This is the primary mechanism for error handling in the app router. Create an error.js file within any root segment where you want to customize error handling. Example, handling errors in a/blog/slug root **. Explanation **. When an error occurs in app/blog/slug/page.js, in this case, if getBlogPost fails or returns null, next.js will render app/blog/slug/error.js. Error prop *. The error prop contains the JavaScript error object that was thrown. You can access its message property to display the error message to the user. Reset prop *. The reset prop is a function provided by next.js. When called, it attempts to re-render the root segment where the error occurred. This is particularly useful for handling transient errors like network issues. Important *. The reset function only re-renders the current segment. It doesn't refresh the entire page. User outer *. The user outer hook is used for client-side navigation, which is required because error.js is a server component by default, and we need an interactive button. By adding use client, we convert it to a client component. Asterisk error logging, use effect. The use effect hook demonstrates logging the error to the console. In a production application, you would replace this with a more robust error logging service, example Sentry, Bugsnag. 2. Global error handling with the root error.js***. Place an error.js file in the root app directory, app/error.js, to catch unhandled errors that bubble up beyond specific root segments. This acts as a fallback for errors not caught by more specific error.js files. Key points asterisk. The root error.js should be a very generic error handler, providing a simple message to the user. Avoid displaying sensitive information here. Always log the error for debugging purposes. 3. Centralized error logging Implement a centralized error logging service to collect and analyze errors that occur in your application. This is crucial for monitoring the health of your application and identifying potential issues. Example with Sentry Explanation This example uses Sentry, a popular error tracking service. You'll need to install it, npm install @sentry/next.js. The sentry.js file initializes Sentry and provides a log error function to capture exceptions. With Sentry is useful for wrapping API routes, see section 5. The before send hook can be used to filter out errors you don't want to track. In the error.js component, we call log error to send the error information to Sentry. This allows you to track and analyze errors in your application. 4. Using try, catch blocks for local error handling Wrap potentially error-prone code within try, catch blocks to handle errors locally. This allows you to gracefully handle errors without relying on the error.js mechanism. Explanation The fetch data function uses a try, catch block to handle potential errors during the API call. If an error occurs, the catch block logs the error and returns a fallback value, in this case, an object with an error property. The component checks for the error property and renders an error message if present. 5. Handling errors in API routes API routes in next.js are serverless functions that execute on the server. It's crucial to handle errors properly in these routes to avoid unexpected behavior. Explanation use a try, catch block to wrap the API logic. Return a next response.json object with an error message and an appropriate HTTP status code, example 500 for server errors. Log the error for debugging. If you are using Sentry, wrap the handler with the withEntry function to send errors directly to Sentry from the API route. 6. Client-side error boundaries with use error boundary ***. While error.js handles server-side errors, client-side errors require a different approach. React error boundaries are the standard way to catch errors during rendering, in lifecycle methods, and in constructors of the whole subtree. You can also use libraries like React Error Boundary to simplify this. However, with server components and the app router, client-side error boundaries become a bit more nuanced. The best practice is often to isolate potential error sources keep the amount of client-side code in server components to a minimum. Delegate complex client-side logic to separate client components. Use React Error Boundary in client components. This library provides a straightforward way to implement error boundaries in your client components. Explanation Error boundary.js *. This client component defines the error boundary. It takes children as a prop and wraps them within the error boundary component from React error boundary. Error fallback *. This component is rendered when an error is caught by the error boundary. It displays an error message and a button to reset the boundary. MyInteractive component.js *. This is an example client component that contains interactive logic. It's wrapped within myInterboundary to catch any errors that might occur within it. Wrapping is key. The MyInteractive component is wrapped in myInterboundary. This ensures that client-side errors in this component don't break the entire application. 7. Using suspense for loading states ***. While not directly related to error handling, suspense can significantly improve the user experience during data fetching, which is a common source of errors. Use suspense to display a loading indicator while data is being fetched, preventing the user from seeing a blank screen or an incomplete UI. Explanation ***. The user profile content component fetches the user data. If the data fetching fails, or the user is not found, it throws an error. The user profile component wraps user profile content within a suspense component. The fallback prop specifies the UI to display while the data is being fetched. In this case, it's a simple loading message. If getUserData throws an error, it will be caught by the nearest error.js file, even though suspense handles the loading state. Best practices and considerations ***. Be specific with error boundaries ***. Place error.js files and error boundaries as close as possible to the components that are likely to throw errors. This allows for more granular error handling. Avoid displaying sensitive information Do not display sensitive information, example API keys, database credentials, in error messages. Provide user-friendly error messages Display clear and concise error messages to the user, explaining what went wrong and what they can do to resolve the issue. Implement logging Log all errors to a centralized error logging service for debugging and analysis. Test your error handling Thoroughly test your error handling logic to ensure that it works as expected. Simulate different error scenarios and verify that the correct error messages are displayed and that errors are logged correctly. Consider performance Be mindful of the performance impact of error handling. Avoid excessive error logging or complex error handling logic that can slow down your application. Server versus client error separation Make a clear distinction between server-side errors and client-side errors and handle them appropriately. Server-side errors are handled by error.js, while client-side errors are handled by React error boundary. Example project structure Here's an example project structure that demonstrates the use of error.js files. Conclusion Handling runtime errors effectively is crucial for building robust and user-friendly next.js 13 applications. By using error.js files, React error boundaries, centralized error logging, and try-catch blocks, you can gracefully handle errors and provide a positive user experience even when things go wrong. Remember to test your error handling thoroughly and continuously monitor your application for errors. By following the best practices outlined in this tutorial, you can build reliable and maintainable next.js applications.